In this video, we are working through some harder SOHCAHTOA trigonometry problems. So these are the type of questions where SOHCAHTOA and right-angled triangles are hidden inside of other shapes. These are all suitable for both foundation and higher, and you can download the questions down below in the description. Let's do this. Hey there guys, welcome back to the channel. If this is your first time here and you're trying to get the best grade in maths you possibly can, let me help. Start now by subscribing. Okay then, first up, I've stuck in the page for SOHCAHTOA from my brand new formula booklet. If you haven't checked it out already, the video is linked down below, containing every formula you need for GCSE maths. You can even get a copy for yourself by going over to my Patreon. So pretty important stuff, make sure you check that out. Okay then, question 1. So, ABCD is a trapezium. Our job is to work out the size of angle CDA to 1 decimal place. So let's work out where this guy is. That's the angle made by going from C to D to A. So it's this angle over on the right. So I'm going to call him theta. Okay, now we know the height of the trapezium, so it's given to us over on the left. It's going to be exactly the same here. So that height is also 6. Now, we're in a right angle triangle where we want an angle and we know one side. So we need to work out now one of these other two sides. So let's look at what we know. We know the base altogether is 24 long. We know the top is 10 long. So we know the base inside of the rectangle is also 10. Now, if we could work out the base of this triangle over on the left, we can add that to 10, take that away from 24, and that is going to leave us with the base of our triangle on the right. So, looking at this guy, if we call the base A, and then, because we're in a right angle triangle with two sides known, we can use Pythagoras to work out this unknown length. So if we also call the height B and the diagonal C, Pythagoras says A squared plus B squared is C squared. Now we want A squared, so we need to subtract B squared. So A squared is C squared minus B squared. So stick in the numbers. A squared is 7.5 squared minus 6 squared. Now that is going to give us 20.25. Now to get A itself, we need to square root. So A is 4.5 5 centimeters. Okay, so now we know this length. So what we can now do is work out the base of the right angle triangle over on the right. So 10 add 4.5 is 14.5, so we want what's left, so 24 minus 14.5 gives us 9.5. So that is now the base of this right-angled triangle. So now we can play SOHCAHTOA, because we want an angle, we have two sides. So, with reference to the angle, we have the opposite and adjacent. So, is it so, no, ka, no, toa, bingo. So, toa tells us tan theta is the opposite over the adjacent. So, 6 over 9.5. So, theta then is the inverse tan. So on your calculator, press shift and tan of 6 over 9.5. And to one decimal place, and that gives us 32.3 degrees. Okay, number 2, work out the area of this parallelogram. Okay, so if you've watched my formula video, you will know, which nobody ever seems to, that the area of a parallelogram is exactly the same as a rectangle. It's base times height. So, how is SOHCAHTOA going to help us here? Well, the problem is we don't know the height. However, if we draw a line down like that, we have now created ourselves a right-angled triangle. So, with regards to the 72-degree angle, we have the opposite and the hypotenuse. So, is it SOH? S-O-H, yes it is. So tells us then sine of theta is the opposite over the hypotenuse, so sine 72 is the opposite divided by 12. Multiply by 12, we get the opposite is 12 sine 72, which to one decimal place is 11.4 centimeters. So then the area is the base times that. So 16 times 11.4. And that gives us 182.4 centimeters squared. Number 3, work out the area of this trapezium. So again, it's in the formula book, here it is. So we add the top and bottom lengths, multiply by h and divide by 2. So, here then, well, we have the top and bottom lengths, so that's good. What we don't have is the height. So again, because we have this angle, this is where SOHCAHTOA is going to help us. So, we can make a triangle by drawing a line down like that. Now, notice how the top and bottom stop in the same place because they both have right angles. That means if the base is 15 and the top length is 11, that means that this little bit, the base of this triangle, is 4. So, with respect to the angle, what we want is the opposite, and what we have is the adjacent. So, no, ka, no, toa, yes. So, toa tells us tan of 64 is the opposite over the adjacent, so O over 4. So we want to get O on its own multiplied through by 4, and we get the opposite is 4 tan 64, which to 1 decimal place is 8.2. Okay, so we now know the height of the trapezium is 8.2. centimeters, so we can now work out the area. So it's 8.2 times 11, add 15, which is 26. All over 2. And that should give you 106.6 centimeters squared. Okay, number 4. Now I know I said at the start all questions are from both tiers. I've just come across this beauty. This one is really higher only, but feel free to give it a go. So, the diagram shows the side view of a step ladder with a horizontal strut of length 48 centimeters. We're told that the strut is 1/3 of the way up the ladder. The diagram shows 2 similar triangles. Our job is to calculate the vertical height, h centimeters, of the ladder. Okay, so how are we going to do this? Well, the first thing we're going to deal with is the fact that the strut is 1/3 of the way up the ladder. So, the length of the ladder overall is 141, so 141 divided by 3 gives us 47 centimeters. So, what that tells us is that from the floor to the strut is 47 centimeters. Now that's not really much use. What is useful is knowing the rest of the length. So 141 minus 47 is 94. Okay, now we were also told that this diagram is symmetrical, so if we draw a line down the centre, that cuts things exactly in half. So the strut, so that's a right angle, so the strut from the ladder to the centre is going to be 24 long. Okay, so now we've made ourselves a right angled triangle where we know two lengths. What that's going to allow us to do is find that angle there. So let's call him theta. Now the reason we want this angle is because this little triangle and the diagram overall are similar, so that means the bottom left angle of the whole step ladder is going to be the same as this. We can then use that with the length of the whole ladder to find the height. So, here then we have the adjacent 24 and the hypotenuse 94. So, cos theta is 24 over 94. Theta then is the inverse cos of 24 over 94. Now that gives us, if we go to one decimal place, 75.2 degrees. Okay, so what that's done is it's told us about this angle here, because they're similar, it's exactly the same as this angle here. Now, using the overall diagram, which is getting a bit messy, so let's make a sketch. Okay, so we now know this angle. We know the hypotenuse is 141. Now what we want is the height of the ladder in our triangle that is the opposite. So, we have the opposite and the hypotenuse. Is it SOH? Yes, it is. So, SOH tells us sine 75.2 is the opposite over 141. To get the opposite on its own, multiplied through by 141, so the opposite is 141 sine 72. Sorry, sine 75.2. Now that gives us, again if we go to one decimal place, we are going to get 134.1 centimetres. Okay then guys, that's the end of another one, so if you found it helpful, please do give us a thumbs up, get subscribed to the channel. If you want any particular topics covered like this, let me know down below in a comment. I have separate playlists for higher and foundation past paper exam questions on all sorts of topics. They are linked down below. I also have walkthroughs of every single AQA and Edexcel past paper so far, those playlists are linked down below too. If you have any questions you want done, you can send them to me on Facebook or Instagram. For now, take it easy, take care.